So we got one log on each side. Then we can drop the log. We use one-to-one property. If log base b of m equals to log base b of n, then m can equal n. M can equal n. Okay? Solve and check for extraneous solutions. So it's kind of like dropping the base to the exponent, and you can just make the m equal to an n and solve for x. That's it. 5x plus 9 equals to 6x.
Oh, so this is just like the other one.
Yeah.
With logs. Oh.
But it has to be of the same base. And it has to have only one log on each side of the equal sign.
What if it has two?
Then you got to combine it using all the properties.
Oh, I see. And then you can solve for it?
Mhm.
It has the same base?
Same way. So it'd be 9 equals x, and then we check for extraneous. Okay, so when we check, it'd be log base 5 of 5 times 9 plus 9 equals to log base 5 of 6 times 9. And that should get me 45 plus 9.
Yeah.
Log 5 would be 54, and 45 plus 9 is 54. So does it work? Yeah, it works like a charm, so no extraneous. Okay? Doing good? No? What's up?
When you're doing the check, do you have to put the logs, or could you just do like what you did to find the answer and just plug it in there?
It depends on the question. So I think if it has the same basis, you're totally okay with just checking these. Still be okay. If it was a question like this one, number 8, you might have to work it out. Yeah. Okay. All right. Here we go. Log base 2. Oh, it's the same thing. You guys are okay with number 2 being skipped?
Yeah.
Number 3? Yeah.
You can
Number
just-
4. Let's do number 4. Yeah.
We trust your judgment.
Is it plugged in
Hmm?
there? What does it mean by M?
It's a balance.
Say again.
What does it mean by M is equal?
Where's the m from? Log base b of m. The m is the argument for the first log. N is the argument for the second log. Exponent. Yep. Yep. Right on the nose.
Hey, bro, you might shoot that.
You got it. Se sabe. You know, you got it. You know it. Yeah.
You keep kicking me with your
That's gross. Why would you want to touch his shoes?
You're literally kicking me. I don't want to touch it, bro.
All right, anyways, we got some weird things happening in my classroom. Here we go. Log y plus 5. What do I do with the log of y plus 5 plus log of 4? What do we get to do? What property allows me to combine these two into one log? Product property. So if you have a sum of 2 logs with the same basis, that means I have something that I can multiply together with. So it should be 4 times y plus 5. What's 4 times y plus 5? Yep. It's 20 equals to log of 72. What's the base on this log?
10.
Okay, I have a feeling someone's going to ask me during the test, Miss Fion, there's no log base here. What's the base? I'm going to take a tally every time someone asks me that. And then whoever that has the most tally, I'm just going to take that many points from your teams. How's that? Yeah? No, I don't want to take it away. How about... I don't know. I feel like I should do something. Maybe a penny for each of those questions. I don't know. Probably not. 4y plus 20 equals 72. Subtract 20, 4y equals to 52. So y must equal to 13.
Wait, so does the number have to be under the G in order for it to be a base?
Yeah.
Yes.
Oh, okay.
It has to be a subscript to the word log.
What?
Subscript?
What that mean?
Subscript.
Oh.
It's the tiny one under.
But if I say under, it might seem like, fractions, so subscript would be right here. Yeah. Okay.
Yeah, you missed like 50 questions.
All right, here we go. What do you do if there's a coefficient to my log? Do you need to go bathroom? I'm recording it. If you miss something, you can pick it up later. 3 log base 7 of 4. What do you do? What do you do? There's a property.
7.
No.
Oh, 3.
What do you do with the 3? It becomes the exponent to the 4.
Why would you move it to the 4?
That's the property of powers for logs.
Is that on the yellow paper?
Mm-hmm.
Oh, okay.
Did you write it?
I did that when I lost my notes, remember? So I don't know if I have to write something. The thing I did.
I hope you do. Do we have the same base logs now?
Yes.
Yep, let's drop it and then we just work with 4 to the 3rd power equals to 4a minus 8. 4 to the 3rd power is 64 equals to 4a minus 8. Add 8 to both sides, we get 72. 4a equals to 72. Then a must equal to 18. Check for extraneous. I forgot to do that on the last one. Check. So we're going to do 3 times log base 7 of 4. Does it equal to log base 7 of 4 times 18 minus 8? Now, do you know how to change? What's the change of base formula? You can do log of a, which is in this case 4 to the 3rd power, over log base 7. And you could put it in as a log base 10 log. Okay? When you put this into your calculator exactly like this, log 4 to the 3rd power, close the parentheses, divide by log of 7 and hit enter, you should have the same value as when you put this in. Okay? So log base 7, 4 times 8 is 72, minus 8, right, is going to get me, sorry,
Ben, your recording is right.
yeah, 64. So you should put it into your calculator as log base 7 of 64. Divide by log of 7. Okay? So you're going to do log, and then it opens the parentheses up right away. Put 64, close the parentheses, divide by log of 7. See what you get. You should get the same decimal as this one.
Where did you go?
It should work. There should be no extraneous on this one. Did you get it? Do you need me to write out the pathway? You, okay. That's for this one on the bottom. For this one, I'll write it in pink here. For the pathway, if you want it. Use the caret to put it into 3rd power with the parentheses, the right parentheses. Then divide by log of 7, then hit enter. And the pink pathway's answer should be the same as the blue pathway. Try it. Make sure you try it. Because during the test, if you're getting it wrong and you're not sure why, I can't help you. If you are getting it wrong right now, I can help you.
Wait, what if you can help us with the 7.5? Or not help? I mean, that would suck, but like, hypothetically, I'm just saying. Save on the phone.
But I was trying to close it. Here's the thing, like towards the end. Okay. All right, we're good? You know what to do with dividing? Okay. You know what to do with powers, layers of wonderfulness there? All right, log equals to a number. Okay. This one's slightly different. It's kind of like the cross between changing it to inverse and solving. So you need literally a log equal to a number. Okay, if you have anything added or subtracted to the log, I need you to move it to the number side. Okay? You guys, I'm really tired of fighting for your attention.
Hey guys.
I really should not have to compete for it every day. Log base 2 of x minus 4 should be rewritten where we have 2 as the base written to the 6th power equals to x minus 4. If your variable that you're trying to solve for is in the exponent, you can't do it this way. If this x minus 4 is actually here, then you can't do it this way. You would have to use log again and use power rule to bring the x down. There's no way you can solve anything with exponent in the, variable in the exponent, okay? So this one, 2 to the 6th power is? 5th power is 32, so 6th power is? Yep. Add 4, so x should equal to 68. Make sure you check. Okay. All right, take a look at 12. Is it log alone or is there something attached to the log here? There's something attached to the log, so we need to move it over by doing inverse operation. And you should get log base 3 of 4x plus 8 equals to 4. Okay, now can I rewrite it? Rewrite it into an exponential form. So it's 3 to the 4th power equals to 4x plus 8. That's why I made you guys practice so many of them for 6-4, because it's essential for you to know how to do this almost automatically from here to there in order for you to solve for x. Okay. So 3 to the 4th power is 81, 4x plus 8, subtract 8, 73 equals to 4x. Divide both sides by 4. X equals to 73 over 4. What do I do after I'm done? Check for extraneous. What do I do with number 13? Do I have single log on the left? Nope. So what do I do? We're going to use product property to write it as one single log. Okay? Then I would have log of 2x times x minus 5 equals to 2. Uh-oh, what's going to happen once I do that? I'm going to have an x squared.
Different things.
Mm-hmm. Say it again?
Isn't it like when there's one and there's one on the bottom is 10?
Mm-hmm.
Doesn't that mean that they both have like the same exact base numbers?
Here?
Yeah.
No. That's a plus sign, not an equal sign. Okay? All right. So now I get to write it as an exponential form. What's my base? What's my base? 10 to the second power equals to 2x squared minus 10x. 10 squared is 100. So I'm going to subtract 100 to put everybody to the right side since it's a quadratic. And then I'm going to take a look. Is there a GCF that I can factor out so I have smaller numbers to deal with? I hope so. What's the GCF? 2. Then I have x squared minus 5x minus 50. I'm not going to use my Xbox. I'm going to use my noggin. You ready? X times 5 times 10 seems to work in this one, doesn't it? So if I do 5 times 10, which one should be the negative? 10 should be the negative, so I get a negative 5. So this one is going to be positive. Then now do I have 2 possible answers? Then you got to check those 2 possible answers. Okay, so x is going to equal either negative 5 or x is going to equal 10. Whether this is true solution or not, you should box them and then go back. If there is something that doesn't work in our checking extraneous step, then just put a line through the equal sign to say they're extraneous. Okay, so I'll check this one in green. So log of 2 times negative 5 plus log of negative 5 minus 5, does it equal 2? So let's see. Log of negative 10 plus log, of negative 10, does it equal 2? So we can combine it using power, right? Negative 10 times negative 10 is 100. What's 10 to the second power equal to? So it works, right? Can you do that on your calculator? Put in log 100. Put it in. Log of 100. What do you get? It should work. Good. Here's the checking step for this one. Log of 2 times 10 plus log of 10 minus 5. Okay. Log of 10 minus 5 is 5. Log of 2 times 10 is 20. So is log of 100 still the same as 2? Should be. Okay. Any questions? You're good? Okay, know that there will be some sort of a quadratic in there. Okay.